quadratics. It all comes from, well, hey, this basic idea. If you got two things, or more for that matter, but if you got two things multiplied together equals 0, there's only one possibility, and that is one of those things must be 0. It's the only way you're going to do it. That's the idea behind quadratic equations. Because you get your quadratic, and hopefully we can factorise it as a binomial product, and then we've got two things multiplied together, that gives 0. And in this case, what do we got? Multiplies together give 18, adds to give 9, 6 and 3. So, x is -6 or x is -3. I suppose there is another line there I haven't written, and most times I probably won't write. Depends how difficult it is. But technically we're saying x plus 6 equals 0 or x plus 3 equals 0. I mean, either of those situations must be true. And that's why it's or and not and. It would be impossible for it to be -6 and -3 at the same time. So the correct language to use there is or. This one's already factorised. You might be looking at it thinking, yeah? Just to point out, don't forget the x. Amazing how many people just give the answer x equals -half on that one, because the x is sitting by itself and they sort of forget about it. There's still two factors there. But of course, us mathematicians, we are incredibly lazy people. So we would like to look for patterns and find quick ways of doing things to save us time. And as I mentioned before, we might spend an incredible amount of time looking for the quick solution. But once we have the quick solution, we can use it again and again. The quadratic formula is a case of that. There it is in all its glory. Negative b plus or minus square root of b squared minus 4ac all over 2a. The challenge is to say it as quick as you can. That's how you impress people. It's 2x squared plus 5x minus 4 equals 0. Now, I don't know, but it's quite likely when you first looked at this formula, your teacher drummed it into your head that the first thing you write down is the actual quadratic formula, and then you substitute in. We tend to do that. The reason we do that is a way of you memorising the formula and you never forget it. Of course you don't need to anymore if that's what you're used to doing. Just plug it straight in. -5 plus or minus the square root of 25 plus 32 in this case all over 4. We end up with -5 plus or minus root 57. 57. 3 goes into 57. That's not good enough. I don't think that simplifies down. I think root 57 stays like that. Over 4. That is, of course, an exact answer. In mathematics, we like exact answers. This is not science. Science can't cope with exact answers. You may have noticed this. They always like you to write down an approximation. No, so many significant figures or whatever it is. We like exact answers. Heaven forbid, but they might. If they do say, to 2 decimal places or something like that, that becomes an approximate answer. We get something like this. We want to make x the subject. Okay, we can do that. We treat it as if it's a quadratic equation. As far as we're concerned, y is just a number. So we make it look like a quadratic. It goes with the constant now because it's just a number. And we can use the quadratic formula. -b plus or minus square root b squared minus 4ac all over 2a. In this case, that third will simplify because 4 goes into both. And of course, you can cancel with the bottom as well now. I said you can cancel with the bottom now. There you go. So you get equals -2 plus or minus the square root of 7 plus y. So that's made x the subject. All right, that's enough of me.